Now we are going ahead with one more important session, the last one in analytical reasoning. What is that one? 3 stages, right? We have already finished the rule based one, next one immediate inferences, and finally complementary pair. So what is this complementary pair? What is the meaning of complementary pair? That we will see. So remember, only we have 3 complementary pairs. So only we have 3 complementary pairs. This one you can easily remember. I will explain you in detail later. So what are all these complementary pairs, how it comes, and why we have mentioned only these complementary pairs are there. Clear? So we have only 3 complementary pairs. One is AO pair, IE pair, and IO pair. One is AO pair, another one is IE pair, the last one is IO pair. So starting with A, 1 pair is there, starting with I, 2 pairs are there. So AO pair, IE pair, IO pair. So we have only 3 complementary pairs. What is the meaning of complementary pair? Complementary pair means between these 2 statements, one statement must be true. One statement must be true. That means one is false, one is true. So if one is false, other one must be true. If other one is false, the first one must be true. Are you getting? First one is false, the second one must be true. Second statement is false, the first statement must be true. Always remember, in complementary pair, one must be a positive statement and another must be a negative statement. Always remember, in complementary pairs, one must be a positive statement, the other one must be a negative statement. See here, so A is a positive statement, O is a negative statement. I is a positive statement and E is a negative statement. Again, I is a positive statement, O is a negative statement. So in all complementary pairs, one must be a positive case, one must be a negative case. So always remember, entire positive cases. That means so both positive cases cannot be a complementary pair. Both statement are negative cases cannot be a complementary pair. Entire positive cases and entire negative cases, A and E. Entire positive means A, entire negative means E. A and E also cannot be a complementary pair. So both positive cases, both negative cases cannot be a complementary pair. Entire positive cases and entire negative cases cannot be a complementary pair. We have only 3 pairs. What are all those? AO pair, IE pair, and IO pair. Always remember, in complementary pair, subject and predicate must be same. Subject and predicate must be same. So this one always we need to remember. In addition to that one, AO pair, IE pair, IO pair, I mentioned as same subject and predicate. For AO pair, subject and predicate must be same. That means what happens sometimes, subject becomes predicate in one statement, predicate becomes subject in the other statement. Whether we can consider those as complementary pair means, for AO pair, subject and predicate also must be same. Positioning also must be same. So AO pair means, say that A example, all white is black. O means some white is not black. Like that only it should be there. So all white is black, some black is not white if it is being given. So sir, subject and predicate both sides are same only, but position is only not same. Whether we can go ahead with the complementary pair means no. So for AO pair, whatever the subject is there, same subject must be for O. For A and O, same subject must be there and the same predicate must be there. For IE and IO pair, subject and predicate, even if interchanges, it's a complementary pair. Same or it can be interchanged, it is a complementary pair. Why we are saying? Because I can be converted into I. Right ma? I can only be converted into I. E can also be converted into E. Even if subject and predicate interchanges, by converting I into I or E into E, you can make same positioning, right? Same positioning. For AO pair, you cannot make that one. Why? Because A can only be converted into I only. A cannot be converted into A statement. A can be converted into the other statement, that is I. So by mentioning A converting into I, you should not say that this is also IO pair, sir. Why can't we convert A into I and say that AO pair is a complementary pair? In case, so if subject and predicate are reversed, definitely not. So once we are telling that AO pair is a complementary pair, subject and predicate of A and O must be same. That one you need to remember. For IE and IO pair, subject and predicate must be same. Even position is interchanged, no issues. So subject and predicate can be interchanged. Why? Because again, see here, I can be converted into I, E can also be converted into E. Here ma I and O, of course O cannot be converted. Suppose subject and predicate are being interchanged, but I can be converted into I. You can make same positioning, subject and predicate, right? That is the reason for IE pair and IO pair, subject and predicate, even if it is interchanged, it is a complementary pair. For AO pair, subject and predicate positioning also very important. It must be same. So we will prove this one using Venn diagram as well. Already we have mentioned this Venn diagram, right, while explaining immediate inferences. So I clearly gave example each one by one how immediate inferences rules came into picture. By using same Venn diagrams, even we can arrive at these three complementary pairs, but not required. If you want to invest your time, if you want to know that one, sir, how it came into picture, these rules and all, I would like to know in detail, yes, you can go ahead and I will give the explanation and see that one and how we arrive at AO pair, IE pair and IO pair. Or else if you remember these three pairs are complementary pairs, that is more than sufficient. In addition to that one, now what is complementary pair? One must be positive, one must be negative. Everything is fine, sir, but still I couldn't understand what is the logic behind that one, right? What is the logic behind that one? Simple example, one example I will give. Madan is married, Madan is unmarried. I have given two statements. Madan is married, Madan is unmarried. Which statement is true? The students are the people who knows about me and who knows that I am married, I am having children. They can definitely say that Madan is married. But the people who do not know about Madan, how can they say that Madan is married or Madan is unmarried, right? So what is the answer they can give? Can they say that Madan may be married or unmarried? Definitely they can say that now. So if I am giving a conclusion, Madan is married or Madan is unmarried, can you definitely tell either of one must be right? Definitely one must be right. If it is he is not married, Madan is unmarried. If he is married, Madan is married. Like that you can tell. That is what the meaning of complementary pair. One must be positive, one must be negative. So first one is negative means definitely the other one must be positive. Or other one is negative means first one must be positive. So the meaning of that complementary pair is one must be positive and one must be negative. You can even ask a person who is residing in Pakistan or in USA or in Australia also whether Madan is married or unmarried. If he doesn't shoot you, you are lucky. Or else definitely he can say that whether Madan is married or unmarried, either of one must be true. 100% they can tell. That is what the meaning of complementary pair. Complementary pair means either of one must be right. So that means if A is wrong, A statement is wrong, 100% O statement must be right. 100% O statement must be right. Same like that, if I statement is wrong, E must be right, or E is wrong, I must be right. Here also, if O is wrong, A must be right. I is wrong, O must be right. O is wrong, I must be right. This is what we are going to discuss in complementary pairs. Are you clear? How many complementary pairs are there? AO pair, IE pair, IO pair. Starting with A, one pair is there. Starting with I, two pairs are there. I repeat, AO pair, IE pair, IO pair. In complementary pairs, one must be a positive statement, another one must be a negative statement. Both positive statements, both negative statements cannot be a complementary pair. Entire positive cases and entire negative cases, A and E cannot be a complementary pair. So why they are not complementary pairs? Other than three, why we don't have any other complementary pairs, that in detail we can discuss based on Venn diagrams. Now we mentioned AO pair, IE pair, IO pair, right? It can be even we can tell OA pair, EI pair, OI pair also, nothing wrong. So it can be AO pair or OA pair. We can tell IE pair or EI pair, IO pair or OI pair, nothing wrong. Why? Because subject and predicate are same. So don't think that a AO pair and OA pair are different and all, nothing like that. Unlike in rule based one. So in rule based one, A plus A is A plus I is not equal to I plus A, right? A plus I gives no conclusion, but I plus A is I. Now this one keep in mind. Now if you are interested, you can go ahead with directly these rules, AO pair, IE pair, IO pair, or so if you want any explanation, you can go through my next explanation in detail given with Venn diagrams. Are you clear? So here how we arrive at AO pair, IE pair and IO pair using Venn diagram. Now I am going to explain, or else just fix your mind. If I say how many complementary pairs are there? 3. Starting with A, AO pair, starting with I, IE pair, again starting with I, IO pair. AO pair, IE pair, IO pair. one must be positive, one must be negative, and subject and predicate must be same. And for AO pair, subject and predicate with the positioning also must be same subject and same predicate. For IE pair and IO pair, subject and predicate, even if it is interchanged, it is a complementary pair. Why? Because I can be converted into I and you can make same positioning. Even in IO pair also, I can be converted into I, you can make same positioning. For IE pair, you can also even convert E also here. Clear? Now we will see that how this AO pair, IE pair, IO pair came into light. So first, what we are going to prove, if A statement is wrong, we need to prove that O statement must be right. Right? So if I statement is wrong, we need to prove that E statement is right. At the same time, if I statement is wrong, we need to prove that O statement is right. This is what we are going to prove. So see that first, A statement is wrong. In Venn diagrams, you remember, for A type statement, 2 diagrams are there. For E type statement, only 1 diagram is there. For I type statement, 4 diagrams are there through Venn diagram, right? For O statement, 3 diagrams are there. Wherever A statement is right, those diagrams, so we are just striking it off. Right? So here we need to consider all the 4 statements Venn diagrams, not only A, all the 4 statements Venn diagrams, where and all A statement come into picture, that is all white is black, where and all it is right, those Venn diagrams we are striking it off. That means they are all wrong. And the remaining whatever the Venn diagrams are there, from that we need to check whether I is right or E is right or O is right. That is how we are concluding whenever A is wrong, the other one must be right. Are you getting, ma'am? Now see that where and all A is right, we need to strike it off. So all white is black, both are strike it off, because both are all white is black. Anywhere we have all white is black, in all these 4 statements Venn diagrams, all white is black, here it is there, this is also wrong. All white is black, this is also ruled out. So anywhere all white is black, that's it. How many are there based on all white is black Venn diagrams? So 1, 2, 3, 4, right? These 4 are ruled out, eliminated. Now remaining how many are there, ma? Here 1, 2, 3, 4, 5, 6. In these 6 Venn diagrams, which statements holds good? Which statement is true? Whether I or E or O, that we need to check. In all 6 Venn diagrams, we need to prove that either I or E or O, which is true. So then only we will go ahead with the complementary pair, right? First one we will consider E statement. First one we will consider E statement. Ruled out, whichever is crossed, that we should not check. Whether E will come here, can we say no, it is black? No, right? If it fails in any one of the diagrams, so no need to even consider. Even it fails here, even it fails here, even it fails here. So E type statement. That is the reason whenever A statement is wrong, we can say that E is also wrong. E is not right. In all the 6 diagrams, E must be right. Then only we can say that A and E is a complementary pair. Here it is not proved. That is the reason A and E is not a complementary pair. Are you getting? That is the reason we are telling entire positive cases and entire negative cases cannot be a complementary pair. Are you getting how we arrived at this AO pair? So of course we haven't proved O is right. We are going to do that one. So E is wrong. Next we are going ahead with I statement. See that whenever A statement is wrong, whether I statement is right in all the 6 diagrams. So I is right here, some white is black, some white is black here also, some white is black, ruled out because no white is black, right? If it fails in any one of the diagrams, we cannot move ahead with that. Here also it fails, right? So whenever A statement is wrong, I statement is also getting wrong in many of the cases. So A and I cannot be a complementary pair. This is what we are going to prove, that both positive cases cannot be a complementary pair. Are you getting? Whenever A is wrong, E is also wrong, I is also wrong. So now what is left over, ma? Only O. If we prove that O also won't come into picture or O also fails in these 6 diagrams, we need to tell that AO is not a complementary pair. AO pair is not a complementary pair. So see here, O, what is O, ma? Some white is not black, right? Some white is not black. Can I say some white is not black? Is it right? Can I say some white is not black? Right? Is it right? So can I say some white is not black? No white is black means some white is not black. That is also true. Some white is not black. Anyway, that statement alone is there. Some white is not black, some white is not black, some white is not black. This is how we are getting AO pair. Whenever A is wrong, O must be right. Now I need to remind you, here I told AO pair with the same position, right? With the same position. You check it here, all white is black, right? All white is black. When I say that some white is not black, that is true here, 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 here. So if I interchange subject and predicate, see that whether that O is right or wrong. If you interchange subject and predicate or O reverse, if you take O reverse, we need to check that whether it is true or wrong. What is O reverse, ma? Some black is not white, right? Some black is not white. So see here, some black is not white. Is it true? Yes. Some black is not white. Is it true? No, right? If it fails in any one of the diagrams, gone. So that is reason AO pair is not a complementary pair if subject and predicate are interchanged. So positioning also must be same. Are you getting, ma? If O reverse if you take, it fails. O straight if you take, some white is not black. Yes, here it is right. Some white is not black is right. Here also right. Here all three Venn diagrams it is right. If I take a reverse, some black is not white. Here it is right. Here it is gone. So here it is right, some black is not white. Here it is gone. So that is the reason AO pair is complementary pair only when positioning also must be same for both subject and predicate. Clear? Now what we are going to prove? If I is wrong, we need to prove that E is right. Are you clear? So where and all I statement is there, we are just taking that one is not true, that is false. We are just striking it off. So where and all I statement means what? We need to get some white is black. Where and all some white is black we are getting in Venn diagrams. In all the four statements, those has to be removed or eliminated, strike it off. Remaining Venn diagrams only we need to check with A, E and also O. So see that I statement, this is wrong, some white is black, this is already wrong, this is also wrong. Some white is black, this also comes na, some white is black means that is reason cross mark, some white is black, this is ruled out, some white is black, this is ruled out. How many left over? Only two Venn diagrams are left over. So no white is black or no black is white. Whenever I statement is wrong, which is right, ma? E statement is right, that is only left over. Even you can take conversion of E also. Either no white is black or no black is white, both are right only. That is reason we are telling same subject and predicate or even subject and predicate are interchanged, we can go ahead with the complementary pair for IE pair. So whenever IE is right, all others are wrong. You see that one, whenever IE is right, you are left with only E statement. So we can't get A statement here, right? In these two statements, we can't get A statement. So that is the reason IE is a complementary pair. Now we have proved whenever IE is wrong, E is right, right? Now third one. So which is the third one? So whenever I is wrong, we need to prove that O must be right. Whenever I is wrong, we need to prove that O must be right. So already we mentioned that where and all I is coming, we just cross that one. So we are left with only these two statements. Here these two are what are all those? Only two, both are E statements only. So no white is black, and here also no white is black or no black is white. E is directly implied by O statement. Here also we can derive O statement. Some white is not black or some black is not white. Here also same. That means whenever I is wrong, O must be right. That is the reason O also came into picture, because E is directly implied by O. Are you clear how we are getting that one? Other than this, you can't get any other complementary pairs. We have only three complementary pairs: AO pair, IE pair and IO pair. So AO pair, subject and predicate with the positioning also must be same. Just remind yourself, because all white is black, some white is not black is true all over, some black is not white means here we are not getting, right? So that always you remember, for AO pair, subject and predicate with the positioning also must be same. IE pair and IO pair, subject and predicate same, and suppose even if it interchanges subject and predicate, there is nothing wrong. So IE pair and IO pair are complementary pairs. Why? Because I can be converted into I or E can be converted into E. You can make same positioning. Clear? So this is what complementary pairs are. How to use these complementary pairs in the examination point of view, that we will discuss in detail. Before that one, always remember, whenever complementary pairs are being given in conclusions, by looking at that directly, you should not move ahead saying that these are all complementary pairs. Why? Because in those two statements, if any one of the statements already we got it as true based on first stage and second stage, rule based one or immediate inferences, if any one of the conclusions already we got it as true, then we should not consider this as complementary pair. In complementary pair, whenever we are saying complementary pair, both statements should not be true based on first two stages. Always remember, whenever we are saying complementary pair, in the conclusion, those two statements should not be true based on first two stages, that is based on rule based one or based on immediate inferences. Those two statements should not be true. Clear? So we will now move ahead in solving the problems in detail as per the examination point of view.